Good morning everyone. In this lecture we are going to learn about some important signals. So we will start with continuous time signal in this lecture, and then we will do for discrete time signal in the following lecture. So the important continuous time signals. The first one is if you have x of t equals to e raised to the power t. So you can say it's an exponentially increasing function in time domain. So if no range is defined, it means the function exists from minus infinite to plus infinite. So if we have to plot this signal, it will be of this form. Exponentially increasing function. So it will be x of t, it will be this, and this will be 0, and this is e raised to the power t. So if we have to say it in terms of the values, so if let's say the first value I put there is t equals to -2. So at t equals to -2, it is x of -2 equals to e raised to the power -2, which is, you can say, 0.37 whole square. At t equals to 0, the function is e raised to the power 0, which is equals to 1. At t equals to 2, this is x2, it's e raised to the power 2. So you can see clearly that in this direction the values of the function is increasing, or the value of the signal is increasing, or you can say when we are going from negative side to positive side, the function is having an increasing nature. So this is the first signal which we are going to use. The next possible format of this signal is if it is written in this way, that x of t equals to e raised to the power t ut, or it is written as e raised to the power minus t ut. So this is a unit step function which I am going to explain just after this, but in another ways you can say that it is equivalent to writing as e raised to the power t for 0 between 0 and infinite, and 0 else, and this one is equivalent writing like infinite and 0 else. Clearly we can say that this is an increasing function of t, and this is a decreasing function of t. What it means is that if I plot them, the first one will be like this. This point is 1, this is 0, and the second one is and this point is 1, this is 0, so this is like this. So you can see clearly that these are increasing and decreasing exponential function on positive hand side. Now what is this unit step function which we are using? It's a very important function and or the signal which is used for the analysis of many communication devices and other applications also. Unit step signal, it is usually defined like this: ut is equals to 1 for t greater than equals to 0 and 0 elsewhere. If at this point I have to plot this ut, then ut will be of this form, that it will be 0 for t less than equals to 0 and it is having a value 1 for all the points which are greater than 0. Now if I have to write for u of minus t, then u of minus t is equals to 1 for t less than equals to 0 and 0 for the remaining points. So at this point you might be wondering why and how we are able to find this range. So I'm telling you an easy way to understand it. Whatever you have here in bracket, put it greater than equals to 0, and from that you can find the points for which this unit step function will be equals to 1, and for the remaining points it is 0. So it is calculated here. The another version of this signal is ut plus a. So put t plus a greater than equals to 0, which means for t greater than equals to minus a, this signal has amplitude equals to 1. These are all different ways of this signal when t is positive. Now if my t is negative, then it's minus t plus a greater than equals to 0. If you take this t to this side, then it will change the polarity, so it will be t less than equals to a. This signal is having amplitude 1 and else it is 0. Now if we have the signal like this, so you can say minus t minus a greater than equals to 0, or you can say t is less than equals to minus a. So you can say it's 1 for 0 else. So now if we want to sketch all of them, so u of so if I have to sketch u of minus t, then it will be this. If I have to sketch u of t minus a, so it will be one, and for the remaining it is 0. Means from a to infinite the function will have an amplitude equals to 1. If I have to sketch it's minus a, then amplitude after minus a, the amplitude is 1 up to infinite. If you have a signal u of minus t plus a, then from a to minus infinite, or you can say from minus infinite to a, or all the negative values which are after a, it has an amplitude depending upon my a is positive or negative. Suppose I am considering now my a is positive. Sorry for that. So it's t, it will be all the points which are less than a, the amplitude is 1, and the last one is u of minus t minus a. So it will be minus a 1. So this has an amplitude equals to 1 for all the values which are on left hand side of a, minus a, or you can say. The other important function which we are going to use in this course is your impulse function, or you can say unit impulse also. And one more thing which I need to say about unit step function is its amplitude is 1, but if you multiply it with any signal, the amplitude of unit step function becomes the amplitude of that signal. If you multiply it with a constant, then that constant becomes, suppose you multiply it with 2, then it will become the amplitude of the signal. Unit impulse function, as the name indicate, it's a impulse, and it is of this form. In time, sorry, they are not equal, but in actual they are equal. So we denote it by it's basically an impulse of width which is equals to delta, and it extends from minus delta by 2 to plus delta by 2. I want to be more specific, plus delta by 2, and the height of this is equals to 1 upon delta. Now this my delta is such that the delta tends to 0. So if my delta tends to 0, what that means is, delta tends to 0 means that delta tends to 0 means 1 upon delta tends to infinite. Now generally the impulse function is shown like this. Okay, so there's an arrow pointing towards upward. So it means actually is that my amplitude of the signal is tending towards infinite. And why it is tending towards infinite? Because the width of the signal is basically tends to 0, which makes the height of the signal tends to infinite. Now if I need to find the area under the pulse, area under the pulse, and it is equals to length into breadth, or height into width, whatever you want to use, equals to 1, so which is a constant. So whatever the condition is, the area under the impulse function is always equals to a constant which is equals to 1. And more generality, we can say that minus infinite to infinite dt is equals to 1, where we can also write that delta t, the impulse function, is equals to limit, means this is equals to this condition is that it delta tends to 0. So we can say that impulse function, the area under it is equals to 1, which is always equals to constant. Now there is another condition which we need to remember for it, is that if it is specified to us in the form of, here we are using infinite to infinite, but if we are using two numbers a and b, so what should be the restriction on a and b? And the restriction should be this, that 0 lies between these two numbers. So that is the restriction imposed on it. Now if I have an impulse function not of this form, but it's like this, that a to b and in order for it to be equals to 1, then my a, or you can say my k, must lie between these two numbers. This is the restriction imposed on it. There are certain conditions or the rules which this impulse function follows, is that if you multiply it with any other function, let's say xt, then this is equals to x of 0. Why? Because we know that delta t is equals to 1 for t equals to 0 and 0 else. So it has value equals to 1 for t equals to 0, and for the remaining point it is equals to 0. So then when we will put t equals to 0, we can write it as minus infinite to infinite x0 delta t dt. Now x0 is basically a constant which can be taken out of the integration, so we can write this. And what is the value of this? This is equals to 1, so we can write it is equals to x0. If we have another one which is written as minus infinite to infinite xt delta t minus t naught dt, so it will be equals to xt naught. How it will be equals to this? Again here again this part, this delta t minus t naught equals to 1 for t equals to t naught and 0 for remaining ones or remaining points, you can say. So this is basically then equals to at t equals to t naught, so we can write minus infinite to infinite x t naught, which can be written as, now this is a constant, x t naught is a constant, can be taken out of integration. This part is equals to 1, so this is equals to this. There's one more thing which should be noted while we are doing this, and that is that delta of minus t is equals to delta of t, because whether you say here minus t equals to 0 or you say here t equals to 0, both are same. T equals to minus 0 is nothing, it's a 0 only. Okay, so in the next lecture I'll cover discrete time signals which we use most commonly. Thank you. Please like, share, subscribe, and if you have any queries or comments, please put it in the comment box. Thank you.